Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 16th, 2026, just yesterday. It introduces a new framework called Query as Anchor that shifts user modeling from static encoding to dynamic, query-aware synthesis, achieving state-of-the-art performance across 10 industrial benchmarks. The paper is titled Query as Anchor, Scenario Adaptive User Representation via Large Language Model. And as we'll see later, the results from large-scale online testing are really impressive, showing significant gains in real-world production systems. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 compares the standard approach with the new Query as Anchor method. On the left, the diagram shows heterogeneous user data, such as transaction logs and search history. The top path, labeled A, represents general user embedding, which creates a single static vector for all tasks, often missing context-specific details. In contrast, the bottom path, labeled B, illustrates the Query as Anchor framework. Here the model uses a specific question to dynamically shift its attention, creating tailored embeddings that adapt to the unique requirements of each business scenario. Figure 2 details the complete three-stage pipeline. On the left, Panel A displays the course-defined user encoder, which processes raw logs like bills into hierarchical representations combined with a specific query. The middle section, Panel B, outlines pre-training, where a dual-tower setup aligns these profiles with target answers using contrastive loss. Finally, Panel C on the right shows the tuning process. Here, the main model is frozen to save compute, and only lightweight soft prompts are updated to adapt the system for specific tasks. Alright, following that pipeline, Table 1 breaks down the datasets used for pre-training and evaluation. The top row highlights the pre-training set, dtrain, which is massive, containing roughly 102 million samples. Below that, the test set dtest is organized into 3 domains: user engagement, risk, and marketing sensitivity. This covers 10 diverse scenarios, ranging from fraud detection to concert click prediction, with each task comprising about 500,000 samples to ensure statistically significant results. So, with the benchmark set, Table 2 presents the main performance results measured by area under the curve. The table compares 3 distinct categories: general embedding models like Q, Hen, and Llama in the top block, specialized user embedding models in the middle, and the proposed Q anchor framework at the bottom. Looking at the final column, the results are clear. The prompt-tuned Q anchor model achieves the highest average AUC of roughly 0.82. This significantly outperforms the strongest general baseline, Llama Embed Nemotron 8B, which scores around 0.75, proving that query-specific adaptation beats static embeddings across diverse industrial tasks. Well, having seen the performance jump in Table 2, Figure 7 now explains the mechanism behind it: attention shifting. The charts compare how strongly the model focuses on different data sources, like bills or search history, before and after prompt tuning. On the left, for the takeout interest task, the model dramatically increases its focus on the bill modality, shown by the blue bar jumping 26%, because spending habits directly predict food orders. In contrast, the right chart for the ant forest scenario shows the model instead boosting attention to SPM, or navigation paths, by roughly 6%. This proves the framework dynamically re-anchors its focus to the most relevant evidence for each specific query. So, Figure 9 visualizes the consequence of that attention shift using t-distributed stochastic neighbor embedding plots. These map complex representations into 2-dimensional points to reveal their structure. The left column displays the universal user embeddings for engagement, risk, and marketing, which appear as unstructured blobs where different behaviors are deeply entangled. But in the right column, the prompt-tuned versions tell a different story. Here, the embeddings snap into clear, distinct groups. For example, in the middle row for risk, the points diverge into 2 well-defined clusters, proving that the model creates specialized boundaries for each business scenario. Wrapping up, the key innovation here is treating user representation as a dynamic question-answering task rather than a static labeling problem. By anchoring the model's focus with specific queries, this framework allows a single system to adapt instantly to diverse business needs, from fraud detection to marketing, without massive retraining. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.